Hello, let's talk a little bit about databases. Chapter 3 focuses on databases. Um, and I want to give you I want to revisit a topic that we had talked about previously, and that is the importance of databases in the business environment. One thing that we generally use databases for is to get a better understanding of the business environment in which we work. We learn more about our customers and their buying habits. We learn about perhaps we discern some information about how can we improve our operations, make them more efficient and more effective. And databases are really at the core of this understanding, so to speak. So let's talk a little bit about the history. In the early days of computing, we used what were called flat file systems. And to give you an understanding of how that works, let's consider, for an instance, here at Chowan. Okay, you may have had a file that would be just a list of students. Okay, you'd have a student file. And that student file would have the student name and their ID and some contact information and things of that sort. Okay. You might also have a, let's say, a file that was being used to keep track of students who were enrolled in a particular course, and perhaps even each course had its own file. But you would have a program that would work with that. You'd have a student enrollment program working with that. Whereas, the previously the contact information, perhaps there was just some kind of a student management system that was keeping track of that. So you have one program that's keeping track of students' addresses and contact information. You had another program that was working with things like the student enrollment in courses. Perhaps you'd have even another program that was talking about faculty members and courses that they were teaching. Okay. The problem with the old flat file system is, let's consider the two situations involving students. You have one that's keeping track of student contact information. You have another that's keeping track by a different vendor, written by a different vendor, that's keeping track of which students are enrolled in which classes. First of all, those two file formats might not have been compatible. Those two vendors might not have talked with each other and set things up to where you could easily get information from one file and incorporate it into the other. Okay. Suppose a student were to get married, female student obviously, and there's a name change involved. Well, if that's the case, you would have to go into both programs and change that student name. You might think to do it in one program, but not to go into the other one. So if that's the case, then you're going to have a situation where the data is not consistent. Okay, that you've introduced some problems in your data sets because, okay, is this student's name Mary Jones or is this student's name Mary Smith? It's hard to tell from the data that we have recorded, so that could be a problem. That situation is called data redundancy. Okay, and the greater data redundancy you have, the more probable it is that you're going to have inaccurate data. And the problem with inaccurate data is that as people use an information system, and they realize that some of the data that they're getting, some of the information that's being produced is not accurate, then you begin to question everything else. You begin to question whether each time you generate a report, well, just how accurate is the information I'm getting here? And you're going to either spend time double checking it, which is a lack of efficiency, or you're simply not going. If you don't want to do that, you say that's just going to take too much time, and you run with the information that you're getting, and it's incorrect. Then it's going to make you less effective. Okay. So the nice thing about a database is it does use a standard file format. The information can be shared amongst multiple applications. Now keep in mind at this point, the applications are not being written by multiple vendors. It's one vendor. It's going to be Oracle, it's going to be Microsoft, it might be someone else. Okay. But that's the advantage of a database system. It helps to eliminate data redundancy. The text talks about the process in which you design a database system. And if you, well, in your first assignment, tutorials A and B, you actually went through that process of designing a database, so you could see what the process is like firsthand. The next topic I'd like to talk about having to do with databases is the methods for accessing files. Okay, and there's a pretty good correlation here. The ways that the text talks, there's really three different methods. Okay, first you've got sequential access. Okay, and that is that in order to get to a particular record, you have to read all the records that precede it. A good example of that might be if you could think about the old Rolodex file. I don't know if you're familiar with Rolodex, but you'd be flipping through the cards one by one until you found the record that you were interested in. Okay. The second form of data access is random access. And that's a more direct access of data. A good example of that would be the CD. You want to listen to track 7, you just tell your CD player, I want to listen to track 7, and within a moment, boom, there you go. Okay, you're listening to track 7. It's almost immediate. Okay, so in terms of computer equipment, okay, well, what do we have that's sequential access? What do we have that is random access? Well, sequential access would be, again, tape. Okay, we've talked about tape, and we still use tape, although the use of tape is limited today to pretty much doing a backup. And that's because when you take a backup, your odds are that if you're going to have to restore from that backup, you're going to want to restore all of the data from that backup. Okay, so if you're going to be processing all the records, then sequential access makes sense. Random access, on the other hand, is useful, say, hard drives, your CD drives, DVDs, things of that sort. They all use direct access. Now, there is a third type of database access method, and that is index sequential. Okay, and index sequential, the file is actually stored sequentially. Okay, so you can treat it as if it is a sequential file and just read all the records straight through. The advantage of that is sequential access is actually faster if you're going to read the entire file. But there's an additional file that's appended to that works with it. It's an index, and it's a small random access file with pointers to point to the different records in the sequential sequential part of the file. Okay, so you're really getting the best of both worlds. Okay, you can treat it as if it's a sequential file, or you can treat it as if it was a random access file, and that's index sequential. The last item that I would like to talk to you about in this introduction to databases has to do with a relational database. Okay, now Microsoft Access is a relational database. Okay, for the most part, it does have some object-oriented features. But basically we treat it as if it's relational. Okay, we're going to talk about relational databases, and essentially the relational database is viewed as being a collection of rows and columns. Looks kind of like a spreadsheet. If you've worked with Access before, you know this should be ringing a bell. The rows correspond to your records, and the columns correspond to the fields within those records. Okay. Okay, so when you're working with Access, one of the things that you do is you create a new table. Okay, now when you create a new table, you do things like you go and you say, well, the field name is going to be student ID. This is going to be, and you define the data type. It's going to be text, or it's going to be Boolean, or it's going to be numeric, whatever. You make that determination. You perhaps put a limit to how long that field is going to be. You might include some validation rules for the field, and so on and so forth. Okay, what you're doing there is you're defining the data dictionary. Okay, you're creating a data dictionary, which is essentially a file within the database that describes the metadata of that database. Now, metadata is a new word for you. Metadata is data about data. Okay, and we'll see that come up a little bit later in the same chapter, but I'll go ahead and introduce the concept now. Metadata is data about data. If you think about the Microsoft Word, if you go into Properties and you look in and you over to the right-hand side of Properties, you'll see all sorts of information: how long that file had been edited, the number of words in the file, who the author of that document was. That is all metadata. There's an example of metadata. Okay, so when you create a table, you're essentially establishing the data dictionary, and it's storing metadata. When you build a query, okay, and in your reading you'll learn about there's really two primary ways in which we build queries. One is by using a structured query language, okay, like SQL. The other is query by example. Access uses QBE for the most part, query by example. The interesting about Access is you use query by example. You're probably familiar with the query screen, and you go in and you add the tables that you're going to be using in your query, and you establish relationships between the tables, and then you are selecting fields from the various tables that you want to have in your query output. And you're also specifying selection criteria. Okay, I want a student zip code is equal to 27870, and it'll pull all the students whose zip codes are 27870, that kind of thing. So let's talk a bit about the three major operations in the database, and those three options are select, project, and join. Okay, select, project, and join. Now, select is the process of selecting the records. Okay, so when we talk about the select command, say in SQL, what we're really talking about is establishing the selection criteria. Okay, again, list all students who live in zip code 27870. When you do that in Access, you're performing a select operation. Project is identifying which fields you want to display in the query output. Okay, so when you go into Access and in your query screen, you have check marks under Show for each of the columns, so you can either turn those on or off. That is the project operation. And then finally, when you execute the whole thing, and what it does is it pulls out bits and pieces of these tables and it combines them back into your results. What you've essentially accomplished is you've created a join. Okay, and so when you actually execute the query, the join occurs, and it's pulling data from multiple tables and building temporarily a new table that will then be displayed to you. That's the join operation. There are other operations. There are some that are update operations, delete operations. We're not too concerned about those here. They don't really, the text doesn't really go into that in any great detail at this point. The three you really should be familiar with are select, project, and join.